This video shows you how to create an ER diagram using MySQL Workbench. So firstly, let's take a look on MySQL Workbench. And after you open MySQL Workbench, you'll be directed to the home page. And it's actually a welcome page showing a welcome message. And on the top, you will see a menu bar. And we can create a ER diagram using data models. So you can simply create a new data model using the file option in the menu bar. And the first one is called new model. And that is the one you can click and it will automatically give you a new data model file and that you can use to create the structure in one new database. After you click a new data model, it will show like this. It's gonna create a tab for you. We call the MySQL model. And basically it's empty. And here it shows you the physical schemas. And basically that is the new name of your database and the tables, views, and other things that you have in the database. But currently that is the new database. You have nothing in physical schemas. Okay, and you can double click the name of the database to change it. So let's call it new database. Okay. So it will change and save automatically, and you can close this one after you change the name of database. If you do have an idea on which table you want to have in your database, you can simply create a table right over here. Or either we will go to the diagram directly to create all the tables and the relationships in a diagram. So in the model overview, we can double click the add diagram and to see a panel which allows you to design the structure in your database. And here is a panel, and it's just like a drawing panel. You can add the objects and you can add the relationship. And in this video, I will show you the basic thing, how to add the relationship and the tables. But here you can see in the catalog tree, we can also add other objects like the views and the routine groups in a database. Okay. So here in the diagram panel, and we have the main panel, which is the place we put our objects. And we also have several options as a small icons on the left-hand side. And that is the thing we can use to add the specific object. And in this video, we care most on the table and the relationship. So in the middle, and there is a small one showing as a table, and that says place a new table. So that is a button you can use to create a new table. So I will just click it. After you click the button, you're gonna click the panel. It will automatically create a new table for you. And now there's no column, and it's just the table itself with a name. Okay. And if you want to change the table and the content, you can double click the table item in the panel. After double click, it will automatically pump up a new panel, and it shows you all the information we can adjust, including the table name and the columns. So we can have the constraints of the column, data types for the column. So we can adjust it here using the panel. So now what I want to do here is that I want to create the tables for orders. And let's see, we have the order information, product information, and the customer information. So that's something I would like to do. Okay. So on the panel, we can also add some text here. This one, so new text object. And if you want to put any notes and anything, you can add it. Okay. So we want to create tables and for this big structure. Okay, right over here. So that's our purpose. And for our first table now, let's say we can see we have some customer information. So the first table, let's create a customer information to store customer, so customer table, and we're gonna store customer information. So the first one is gonna be our customer ID, and for under column panel, and you can double click to add the new columns. And you can also always double click to change the column name and the data tab. For data tab, that is a drop down menu, and you can change the tab. So for ID, we will keep it as an integer. And the second one, we're gonna do a customer name, and that is a varchar. And you can adjust the length of the number of characters. So let's put it 100. Okay. So those are the two columns I have now in my customer table. And then let's create another table to store our item information. So similarly, and we just change the table name and add the columns that relevant to each item, and we will create the item table. So now I create 4 tables: customer table, item table, shop table, and the order table. And each table stores its own information. And now let's build the relationship between our tables. So firstly, let's consider our customer and the order. And when we talk about relationship between 2 tables, there are 3 types of relationship: one-to-one relationship, one-to-many relationship, and many-to-many relationship. Relationships are defined here also on the sidebar, small icons, and we have one-to-one, one to n, it means one-to-many, and n to m, it means many-to-many relationship. And there is just the difference in MySQL. In MySQL, it has 2 types of one-to-one, one-to-many relationship. So you can see one is a dashed line, another is a solid line. So the main difference is that the first one here is called a non-identifying relationship. And the one with a solid line is called identifying relationship. So the difference is that for identifying relationship, and the children table cannot be uniquely identified without the parent table. So it means that the 2 tables, and the ones fully depend on another. So one example is that for student grade. So if you have a grade table and a student table, and the grade table will be meaningful only if we link it to the student table. So whenever you have a student's grade, that is meaningful. But if you only have the grade value, saying 90 or 80, it is not meaningful at all. So in this case, that's called identifying relationship. Non-identifying means that the 2 tables can exist separately. So in our case, like item table, item has its own information. So Apple, like it has its own name, and orange, different kind of orange has its own names and description. So the table can exist independently. And the shop table similarly can exist independently. So the relationship here will be a non-identifying relationship. So that is the difference between the dashed line and the solid line. For many-to-many relationship, we only have 1. Okay. All right, so let's come back to our relationship, the order and the customer. So now let's think about the relationship in these 2. And the customers, they may place orders, and maybe 1 or maybe several orders. So then for sure, there is a one-to-many relationship, and from customer to order. And then for each order can be placed only by 1 customer or 1 user. And then for reverse way from order to customer, that is actually a many-to-one relationship. So 1 order will only find 1 customer, but 1 customer can be associated with multiple orders. So we're gonna do a one-to-many relationship here. So now let's do one-to-many, and we're gonna use this non-identifying, so the dashed line. And in MySQL Workbench, what we're gonna do is we click the relationship first, and then we will click the two tables which has a relationship. The order matters since it's a one-to-many relationship, and we will click the children table, which is a many table first. So in this case, a many table is the order. So we click order table first, and then you can see is a small orange like a frame and on the order table. And then we click the customer table to build the relationship. And now you can see we build the relationship, and there is a line that established between the two tables. And on the customer side, it's just a one node. On order side, it's a like multiple nodes. And automatically, MySQL Workbench will add a foreign key on the order table. It called the customer ID customer. So it indicates that and this is a foreign key referring to ID customer column in customer table. So that's a primary key in customer table. Okay, so that is how we build the relationship. And we have this foreign key, and because when we check a particular order, we want to see, okay, who made this order and what's the name of the customer. Then after I locate a particular order using order ID, I can check the value in the foreign key and further referring to the customer table and saying, okay, that is the ID for the customer, and you can give me the information of this customer. So that is the purpose of the foreign key. And that is how the relationship got built. And also when we try to access the data from two tables, we can use the join syntax. The join condition will be placed on the customer ID column in customer table, and this foreign key column in order table. All right. So that is the relationship between customer and order. And now we're gonna think about the other two tables, the item and the shop. So each item, and that is shown as a single record in the item table. And then we know that each item can be sold in multiple stores or shops. So then here we have a one item to multiple shops. So that's a one-to-many relationship from item to shop. And each shop here, it can sell multiple items. So from shop to item, it's also one-to-many relationship. So it means that we actually have a many-to-many relationship between item and the shop. So then we're gonna use this many-to-many relationship in MySQL Workbench. So we click the many-to-many, and now we just click the two tables one by one, the first one and the second one. After we build the many-to-many relationship automatically, MySQL Workbench will create a new table for us. And mainly because when we design the relationship, many-to-many is a concept. It's a conceptual relationship. When we put the tables into a real physical schema, so we don't maintain many-to-many relationship. Instead, we only maintain one-to-one and one-to-many relationship. So for many-to-many relationship, we will build such relationship through we call the mapping table. So here the mapping table will store the primary key from item table and the shop table. And we can see, okay, item A and which shop is selling item A. So we can use the primary key value and check our mapping table, and we may find multiple records. So multiple shops are selling this particular item. And similarly, one shop, what kind of product is selling, and we can also check using the shop ID, and we locate the mapping table. We can find the multiple records, multiple item IDs that is selling, that is sold in a particular shop. And if you want more information for each item, we can further combine it with the item table. So that is how RDBMS is dealing with that. and the MySQL database design tool will automatically create the mapping table for us. And the mapping table itself, automatically, it will only take two primary keys from two tables and as the columns, and it will only have that column in the table, but we can always add more attributes. So let's say in our original table, we do have one more thing, item price, that's not set anywhere. So we haven't put it anywhere in any table. And because the item price for one particular item may differ if it's sold in different store, and also different items will have different price. So item price is associated with item and the shop. So that's something we can put in our mapping table. So we can double click the mapping table to modify it by adding a new column. Let's call it price. Okay. So I'm gonna set this as let me do a double. Okay. So that will be the new column, a regular column. So price. After you locate a particular item in a particular store, you will know the price. So that is the information here, and that is how we build a many-to-many relationship between two tables. Okay. And now we have this one. If we take a look on the original data set, and we see that that is order information, and each order may contain several items from several shops, and that is something we may have. And then we can further build a relationship between our order and the item shop information. So in reality, what we can do is that the order is not associated with a particular item, but also the shop. So we want to build a relationship into both item and the shop. So what we can do is that we can simply link our order table into the mapping table, item and shop. So that will help us. If one order contains several items from several locations, then we can use the mapping table to check it. And now in our data set, we assume that one order and we only buy one particular item from one place. So then one order only pick one item and shop. In this case, we can build a one-to-one relationship between our order and the item. So that will be a one-to-one relationship. And again, automatically in our order table, the system will automatically add two more columns. So one referring to the ID of item, another is the ID of shop. So in a primary in the mapping table, then that is a primary key in the mapping table. So now for a particular order, we can use the order ID and to check who places the order. So that is by customer ID. And we can also check which item got purchased in this order, so by item ID, and where the order got placed, so by the shop ID. So that will be the final design of my design for this data set. And now we have 5 different tables and with a certain number of columns in each table. And now you can, if you're done or you just finish your work for now, and you can close the tab. And the diagram will automatically saved from this data model. And you can always double click it to resume your diagram and just to resume where you left. And if you want to save it, you can close it and just save this diagram. You can use the same button and to save the data model into a file, and you can save the file on your file system. You can always open the data model using the file button, open model, to open the data model from a file. MySQL Workbench also provides you a way to convert your design structure into real database. So now you can see our physical schemas. After you design it using diagram, automatically it will create it will list the tables and their physical schemas. So now if you want to convert the diagram directly into a database structure, and you will have 5 tables in total in that database. And here is a database name, and those will be the table name for each database. Now, if we want to do so, we don't need to manually create each table using SQL query. We can use a tool provided by Workbench. And in the menu bar, under database option, so you click that, there is one thing called the forward engineer. So that is the option can help you to convert your design into an actual database. You can click forward engineer and it will allow you to set a connection to a database, and you can convert your design to a database on any database server just to make sure you have the credential for your connection. After you set the connection, you can go to next and check some options. After that, you just keep going next and see which item you want to export, and do you want to set any filter, and do you want to convert all tables or just several tables. And you can go to next. It will show you a preview of creation queries that the server or the MySQL Workbench will execute for you. If you think it's okay, you can click next and just wait after the whole converting process is done. So after that, you can close the panel and come back to your database to check whether you have the database ready on your server. So that will be it for the diagram and how we can use a tool provided by MySQL Workbench to design the structure of the database. And that provides us a clear, virtualization or presentation way for us to see structure in our database.